All right, day 2 for 2.3. Two things we're going to go over. Two main theorems are what called the remainder and factor theorems. And you're going to see again how from the last video when we did synthetic division, how we're going to relate factors and zeros to the actual zeros of a function, how they kind of go hand in hand. And we're going to use this really to find zeros of a function or to find factors of a function. Okay, for A, you can see I have the work already out. You can put this in your calculator. Now, we're first going to kind of do a discovering activity where we're going to discover what the remainder theorem is. Now, you're given this function of x, and for A, you want to find function of negative 2. So what that means is you want to plug in negative 2 for all these x's, and that's what I did right here. So just go ahead, you can stop the video, put this in, that whole 3 times negative 2 cubed, and keep going all the way down, and see what you get for it. So you can stop the video, see what you get when you put negative 2 in for x. Okay, when you put negative 2 in for x, you should have gotten this to equal, so I'll just put f of negative 2. When you put this in your calculator, you get this to equal negative 9. Okay? You've done this before, where you just plug values in for x. Now, why are we doing this? We can relate this to synthetic division. Now I'm going to tie part A and part B. I'm going to tie these together. Now I'm going to take f of x, I'm going to divide it by x plus 2. Now from the last video, we could use either long or synthetic division. Well, if we're just dividing by x, we're going to use synthetic. Synthetic is a lot easier. Now if we're dividing by x plus 2, we take the opposite of this, so we're going to do negative 2. So I'm going to put, let's see here, I'm just going to erase some of this stuff here. So it's not working, that part right there. I'm going to squeeze it in up here. Let's squeeze it in here. Okay, I'm going to put negative 2, top left. I'm going to put the coefficients for this f of x. So I'm going to put 3, 8, 5, and negative 7. Okay, I'm going to bring down this 3. Then I multiply. Negative 2 times 3 is negative 6. I add 8 plus negative 6 is 2. 2 times negative 2 is negative 4. 5 plus negative 4 is 1. And then negative 2 times 1 is negative 2. And when I add these, I get negative 9. All right, now here's what we conclude. When you put negative 2 for part A in, the answer was negative 9. When I put negative 2, kind of like I put negative 2 in for x, when I use synthetic division for negative 2, my remainder was the same exact thing here when you evaluated the function. That's always going to be the case. All right, so our remainder theorem, let's conclude what we just did there. And you can see actually doing synthetic division for this is probably even a lot easier than plugging negative 2 in for all these x's and even using your calculator. So it's kind of a shortcut using synthetic division. So what our remainder theorem says is we're going to put, okay, you can write this down. We're going to write if f of x is divided by x minus k, then what we can say is that the function of k equals the remainder. We'll say r, which is the remainder when you use synthetic division. All right. So there it is. If I'm dividing by x minus k, well, in this case, k was negative 2. So I put negative 2 in here. My remainder was negative 9. So function of negative 2 equals negative 9. All right, let's apply this to problem number 1. All right, we're going to use this remainder theorem. Okay, it says find the function of 2. Well, I know I could plug in 2 for all these x's, but it says use synthetic division. That's even shorter. It's quicker. I don't have to do 2 to the 4th or do 2 cubed. So if I want to find the function of 2, I'm just going to take that 2. I'm going to use that for synthetic division. I'm going to put all the coefficients. I have 2x to the 4th, so I have 2, 7x cubed, negative 4x squared, negative 27, negative 18. And I'm just going to use synthetic division for it. So I bring down the 2. 2 times 2 is 4. 7 plus 4 is 11. 2 times 11 is 22. Negative 4 plus 22 is what, 18. Then 2 times 18 is 36. Negative 27 plus 36 is 9. And then 2 times 9 is 18. And when I add this, I actually get a remainder of 0. This is my remainder. So the function of 2 equals 0. Okay? Now that'll kind of lead into, I did this for a reason, this will lead into factor theorem. Now, if your remainder is 0, what I just proved here, and this leads into our factor theorem, if f of 2 is 0, or if x equals 2 is a 0, x minus 2 is a factor of f of x. Okay, 2 is a 0, so therefore x minus 2 is a factor. So factor theorem really relates to remainder. Basically what the factor theorem says is if you do synthetic division and you get a remainder of 0, then x minus whatever this number is, in this case it's 2, that's a factor of f of x. So let's list that here. Officially, let's put it here. Let's put f of x has a factor. Okay, we'll say f of x has a factor, x minus k, if the function of k equals 0. Again, that just means that the remainder gives you 0. This is what we're going to do the next couple of days. This is what you want. You want the remainder to be 0 because you can find the zeros of the function and then also find the factors of the function, which are x minus k. All right, we're going to tie all this together now, okay, for 2 and 3. Okay, for number 2, it's saying, all right, prove that x plus 3 is a factor of that 2x cubed plus 11x squared plus 18x plus 9. Now, the key word here, it says prove. So basically what it means is it's saying, all right, x plus 3, yeah, it's a factor for it. Show that it is. Well, I could use the factor theorem. Basically, if x plus 3, if that's a factor, then this means that x equals negative 3. That should be a 0 of f of x. So when I use synthetic division, I'm going to put negative 3 in the top left-hand corner. Then I'm going to put all the coefficients for f of x, so it's 2, the 11, the 18, and the 9. So let's put that 2, 11, 18, and 9. So since it says prove, this is what I better get. I better get a remainder of 0. If I didn't, then I did something wrong. Okay, so let's do synthetic division. I bring down the 2. Okay, negative 3 times 2 is negative 6. 11 minus 6 is 5. Negative 3 times 5 is negative 15. 18 minus 15 is what, 3. And then negative 3 times 3 is negative 9. That works. 9 minus 9 gives me 0. So I proved it. So I'll just put a check mark. I basically proved that the function of negative 3 equals 0. So negative 3 is a 0. So therefore, x plus 3 is a factor. Okay, very last one. See if you can do the last one on your own. So now look at number 3. It's different. It's leaving it open for you. Saying is x minus 2 a factor? All right, doesn't say prove. So it might be a factor. It might not be a factor. So you can stop the video, do this one right now, and then you can watch the video, see if you're right. All right, so let's do this. Okay, if x minus 2, if that's a factor, all right, if we're saying that's a factor, then what we're also proving is that x equals 2 is a 0. So what this is telling me is 2, I have to use in the upper left-hand part. And then let's put all the coefficients, 2, 3, negative 1, and 4. So 2, 3, negative 1, and 4. Okay, I bring down the 2. 2 times 2 is 4. 3 plus 4 is 7. 2 times that, 7 is 14. Negative 1 plus 14 is 13. 2 times 13 is what? 26. And then when I add 4 and 26, it gives me 30. So this doesn't give me 0. So the answer to this is no, it's not a factor. What I could also prove, if I use the remainder theorem, I prove that the function of 2 equals 30. So therefore, 2 is not a 0. So x minus 2 is not a factor. All right, so make sure to look over these again. Factor and remainder theorem, it's almost kind of the same thing, but we're just relating the factors of a function and the zeros of a function. They go hand in hand.